Hello friends, welcome back. Hearty welcome to you. In this session, we will look into multiples. Now, what is the meaning of multiple of a number? Let us say we want to find out the multiples of 4. So, the multiples of 4 will be 4 into 1, 4, 4 into 2, 8, 4 into 3, 12, 4 into 4, 16. Or can we say that just go on add 4 to the whatever the value we got, because we know continuous addition is multiplication. So the multiples of 4 are 4 table are 4, 8, 12, 16, 20. Now what is the meaning of least common multiple, or first what are common multiples? Let us take for example we have 6 and 8 are two numbers we are considering. Let's find out the multiples of 6. Multiples of 6 are 6, 12, 18, 24, 30, 36, like that. Multiples of 8 are 8, 16, 24, 32, 40, 48. Here we can also do little bit more, 42, then we have 48, and we can go. Now what are the common multiples of 6 and 8? 6 is not there, 12 is not there, 18 is not there, 24 is present. So 24 is one common multiple. Then again 30, no, 36, no, 42, 48. 48 is a common multiple. Now out of them, out of 24 and 48, what is the least common multiple? That is 24. So the LCM of 6 and 8 is 24. Now one way is we can find out like that. Another way what we can do is we can take both the numbers 6 and 8. We'll do another method also. One method we can just start with prime numbers. 2 3s are, 2 4s are, then again 3, 1 and 4. Again with 4 I have 1 comma 1. So the LCM is 2 into 3 into 4, which is equal to 24. Now there is another method how we can find out the LCM, because if it is a big numbers, maybe it's a little bit difficult to do by any one of these methods. So the other method what we have for, we'll take 6 and 8 only. 6 prime factorization, this is prime factorization method, 2 into 3, and 8 prime factorization is 2 cube. Now what is the logic to find out the LCM by this method? The LCM is given by product of greatest powers all factors. If you remember, for HCF or G.C.D, we were doing only the common factors least powers. Now it is greatest powers of all factors or all divisors. So what will be our answer then? LCM of 6 and 8 will be 2. What is the greatest power for 2? 2 cube. For 3 there is only 1. So that is 2 cube into 3, which is equal to 8 into 3, which is equal to 24. Now let us take another example and look by prime factorization method how we can find out the LCM. Let's consider two numbers. We'll take 24 and 90, small numbers. We need to find out LCM of 24 comma 90. Now how we can write 24? Prime factorization. We have 24 equal to 2 cube into 3. What is 90? How we can write 90? 2 into 45, that is 3 into 15. So can I write down 2 into 3 square into 5. Now whatever we did last time, if you remember how to find out the HCF, and just now we know how to find out LCM. HCF is given by product of the least powers of common factors. What are common factors? 2 and 3 are common factors. What is the least power? Here least power is 1, so 2 into, here the least power is 1, so 2 into 3, that is equal to 6. Now what is LCM? Product of greatest powers. So 2 into power is 3 now, and for 3 it is 2, and then we have 5, because LCM is given by product of greatest powers of all factors. So let's do that. 2 cube is 8, 3 square is 9, 9 into 5, which is 8 into 9, 72, 72 into 5 is 360. Now, is there a relation between HCF and LCM? Yes. The relation is, let us say n1, n2 are two numbers, then n1 into n2 equal to HCF of n1 comma n2 multiply with LCM of n1 comma n2. Let us check that. In this particular example, let us say the numbers are now n1 is 24 and n2 is 90. So 24 into 90 is equal to HCF of 24 and 90, we know that is 6, multiply with LCM, which is equal to 360. We can cross check that. We have 24 into 90, 2160, and 6 into 360 also 2160. So HCF into LCM of two numbers equal to n1 into n2, or product of two numbers equal to product of HCF into product of LCM of those two numbers. Now let us try to solve some more problems related to divisors and multiples and prime numbers together. How many positive integers less than 101 are multiples of either 5 or 7 but not both at once? How many positive integers less than 101 are multiples of either 5 or 7 but not both at once? First let's find out how many multiples of 5 are there. So multiples of 5 less than 101 will be less than 101, that is 100 max, 100 divided by 5, so that's 20 multiples of 5. Then how many multiples of 7 are there? 7 maximum number we can go is 98, 7 14s are 7 into 1 to 7 into 14, so 98 by 7, those are 14. Now we have 20 multiples of 5 and we have 14 multiples of 7, but in these multiples we also have those numbers which are multiple of both 5 and 7. So what are the numbers which are multiple of both 5 and 7? Those are nothing but LCM and the product of, or the LCM and multiples of LCM. Now what is LCM of 5 and 7? 35. So if you look at the numbers whatever we have less than 101, we have numbers 35, 70, which are multiples of both 5 and 7. So what we will do now, first we will take multiples of only 5, that is 20. From there we will subtract these multiples of both 5 and 7. So then we will go to multiples of 7, they are 14. From them again we have to subtract the common multiple of both 5 and 7, that is 35 and 70. Two values I have to subtract again. So it will be 18 plus 12, which is equal to 30. So there are 30 positive integers less than 101 which are multiples of either 5 or 7 but not both at once. Now so whenever we have been asked not both at once, what we have to do? Do separately multiples of 5, separately multiples of 14, then subtract 2 times the common multiples of 5 and 7 are the LCM and the multiples of LCM. How many values are there? Those values we have to subtract 2 times. So the positive integers, how many positive integers less than 101 are multiples of either 5 or 7 but not both at once? They are 30. Let's do one more problem. Let's look at this interesting example. Find the prime number p such that there are integers a, b, c and d which satisfy the system of equations a plus b plus c equal to p minus 3, a plus b plus d equal to p plus 1, a plus c plus d equal to 2p plus 2 and b plus c plus d equal to p. We have to find out the prime number p such that there are integers a, b, c and d which satisfy the system of equations. So we have to find out the value of p and also the values of a, b, c and d. Now to solve this problem, what we will do, we will add left hand side and right hand side. All these equations whatever is given to us, we will get 3a plus 3b plus 3c plus 3d equal to 1, 2, 3, 4, 5, 5p minus 3 plus 3. So we get 3 into a plus b plus c plus d is equal to 5 into p. Now we have been given that p is a prime number. That means from this equation, without considering p as a prime number, the p values will be 3 or multiples of 3. P value can be 3 or multiples of 3. But we know p is a prime number, so p value is equal to 3. Now once we know p equal to 3, we can go back and write down given equations again as a plus b plus c is equal to 3 minus 3, that is 0. The next one we can write down a plus b plus d is equal to p plus 1, that is 4. Then we have a plus c plus d which is equal to 2p plus 2, that is 8. Then we have b plus c plus d which is equal to p which is equal to 3. Now once we know p equal to 3, automatically we know that a plus b plus c plus d is equal to 5, because 3 into 5 should be equal to 5 into 3. Now a plus b plus c plus d equal to 5. So we know that. Then we can easily find out the values. A plus b plus c equal to 0. But we know a plus b plus c plus d equal to 5. That means d equal to 5. A plus b plus d equal to 4. But we know a plus b plus c plus d equal to 5. That means c equal to 1. We know that a plus b plus c plus d equal to 5, and also we know a plus c plus d equal to 8. Now what should we add to get it 5? That is b equal to minus 3. We know a plus b plus c plus d equal to 5, and we know b plus c plus d equal to 3. That means a should be equal to 2. So the values of a, b, c, d and p are given by a is 2, b is minus 3, c is 1, d is 5 and p is equal to 3. So that's one interesting example. Once we understand that, we have to add all of them on right hand side and left hand side, because we see that when we add these numbers, integers will cancel out and we get 5 into p, and here we are getting 3 into a plus b plus c plus d. So then we know automatically that p should be 3 or multiple of 3, but we know that p is a prime number, so only this is ruled out. P is 3. If p is 3, automatically a plus b plus c plus d will be equal to 5. Now we go back and do back substitution. We get the values of a, b, c, d. So in this session we understood about multiples, common multiples, how to find out the LCM, and we also did some problems related to divisors, prime numbers and multiples. So thanks for your time and support. Please do let me know your feedback. Bye for now.